Hey, Gradius here. This is a video for graphing linear inequalities. Okay, so make sure we have to make sure we've watched all the other videos and we know how to graph a line, so we know how to graph linear equations, and we have to know also what slope-intercept form is. So if you haven't watched those videos yet, please go back and do so now, because this video is going to expect that you know those skills. Okay, so graphing linear inequalities, you guys, is when inequalities, instead of having an equal sign, we have the inequality symbol. Okay, but it really is the same thing as graphing linear equations, except for we have two extra steps. Okay, so the first step is to graph the same as an equation. Okay, so we still use our y-intercept, we still use the slope in the exact same way to graph a couple points and then connect those points. Step 2, however, is when things get a little bit different because we have to determine if we're using a solid line or dashed line for our graph when we're connecting the points. And I'll show you a trick on how to do that, and I'll show you why we have the difference. And step 3 is when we check a point and we have to shade our solution. Because it's an inequality, there's not just it's the line, but there's also going to be, because it's less than or greater than, there's infinite solutions on either side of the line. And we'll show what that means as well. So the first thing, let's look at this graph, and let's just let's plot our points. Let's find our y-intercept and our slope. So our y-intercept is positive 1 here. So that means I have a point on this graph of 0, 1, because that's my y-intercept. So that's where I'm going to start. Okay. Now I use my slope. Rise is 1, the run is 2. So up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. I've got a positive slope here. Now I'm going to stop here, and I'm not going to connect my line. Because then what I need to do is I need to now move over to step 2, determine if when I make my line, am I going to use a solid or a dashed line? And that's where this symbol comes into play. Okay, so what I want to do is I want to go to the next slide real quick. We'll come back. So when we use a solid line or dashed line, here's what we know. If we do not have the or equal to symbol, we use a dashed line. Okay, so if it's just less than or if it's greater than, that's when we connect we make our line with actually a dashed line. Okay, if we have the or equal to symbol underneath, that's when we use a solid line. Okay, the reason why, you guys, is it's very similar to when we graph just inequalities in general in a number line. If I were just to graph x is less than 2, okay, we would have found 2 on a number line, and then we would have used an open circle and shaded it to the left. The reason why is because x is less than 2. 2 is not a part of this inequality. Okay, because 2 is not a part of this inequality, we put a hole on 2 saying this isn't part of my solution, but everything to the left is. Well, it's the same thing here. If I have a dashed line, it's saying, well, anything on this line is actually not a part of, does not make this inequality true. Okay, so anything on this dashed line, so it's broken up because it's saying this is a broken line. This isn't part of my solution. Okay, but everything to the left or to the right of it will be, and we'll show that's the shading part. Okay, and the solid line is where we include it and saying, yeah, this is part of the solution and everything to the left. And that's when we put the or equal to symbol underneath. Okay, so dashed line, these symbols, okay, no or equal to, solid line when we have the or equal to symbols there. So I have my lines. I need to look, do I have a solid line or a dashed line? Because it's just y is less than this line, what I'm going to do is I know because there's no or equal to symbol, that means this line is going to be a dashed line because it's not part of the solution. So I just kind of dash it instead of make a solid straight line. Okay. So that's step 2. So we used a dashed line. Okay, so that's one of the differences with inequalities. The final step is we need to check a point and shade our solution. So here's what I mean by that. So with an inequality we're saying y is less than all of this. So that means I actually have to do some shading, okay, to figure out what is going to be less than this line. Okay, so what we do is we check a point. So here's what I mean by that. Again, if I use just a regular inequality, if I was just to look at, I'm really sorry, I don't know why it's doing this. If I'm looking at x is less than, sorry guys, it's less than 4. Is my solution, I have infinite solutions. There's infinite possibilities of things that are less than 4. Okay, so if I have an inequality, there's always going to be more than one possible solution that's going to satisfy this inequality. So we want to show what side of the graph are those solutions that satisfy it. And the way we do that is we just pick a point on our graph and we test it. Okay, the point I always suggest, and we plug it in and we test it, the point I always suggest picking is 0, 0. okay? Because 0, 0 is really, really easy, okay? So what we can do is, because in every in slope-intercept form, the y and the x, they always represent points on the graph. Okay, this represents any point that's a part of this graph. Okay, that would make this inequality true, make this statement true. So if I plug in the point 0, 0 in for my x and my y, okay, I'm going to be able to determine if that makes the inequality true. So here's what I mean by that. So if I plug it in, 0 is less than 1/2 times 0 plus 1. Well, this goes away. So I just get 0 is less than 1. And I need to ask myself, is this a true statement? Is 0 less than 1? And it is. So the point 0, 0 makes this inequality true. If I plug in 0, 0 for my x and my y, that ordered pair, and I work out and I solve, it actually makes this true because 0 is less than 1. So this is part of the solution. This point right here is part of the solution to this inequality, to this graph. Okay? That means that every single point on this side of the line would actually make it true. So what I can do is I actually shade in all of this side of the graph. I shade it in nice and lightly. I know this doesn't look very light, but we shade it in nice and light with your pencil to show that every solution on this side of this dashed line is part of the solution. Every point on this side of the line, if I plug in into this inequality, it would be a true statement. And I can pick any point. I could pick this point right here. I could pick 3, -1. If I were to plug in 3, -1 in here, it would be a true statement. If I plugged in 0, 5, okay, it would not be a true statement. Okay, it would not. So that's because it's not a part of the solution. Okay, I know that was a lot, so we'll go slowly and we'll keep looking at this with a couple more examples. Okay, and then one real quick, guys, a little trick to help you memorize this. And again, I think I showed some people this in the past in other videos too, is in different inequality videos. Is there's faces that we can draw. Okay, so if it's less than or equal to, we always have a closed circle. There's a nose, and we have a dashed line. So there's one face. And if it's or equal to, we have a closed nose and a solid line. So these two faces kind of help us remember when to use a solid line and dashed line, if you like those faces or not. Okay, so I'm going to graph this following linear inequality. So I have -3x minus 1. So again, step one, we just graph it like normal. And then we determine if we use a solid line or a dashed line. Okay, so my y-intercept is -1, so that's where I'm going to start. Okay, and then I use my slope of -3, but let's put it over 1 just to help us. So I go down 3 over 1, down 3 over 1. I can also go up 3 over 1, up 3 over 1. Now I got to look at my symbol here and ask myself, am I using a solid or a dashed line? Because it has the or equal to symbol, that means the line would actually be part of the solution to the inequality. So that means it's a solid line, saying that that's included. Okay, so then now what I want to do is, because this is part of the solution, now what I need to do is I need to determine which side of the graph do I shade. So I need to find a point that is on either side of the graph. It doesn't matter. Okay, I need to find a point that's on either side, and I need to test it. Okay, what I always want to try to do is test 0, 0. Okay, if I can. If the line does not go through 0, 0, I can test that point. If my line does go through 0, 0, I need to choose a different point. Okay, but we always try to choose easy numbers like 0, 0, or 1, 1. Okay, the reason why I like 0, 0 is if I plug in the point 0, 0, I get 0 is less than or equal to -3 times 0 minus 1. This is always guaranteed to cancel out, so I just get 0 is greater than or equal to -1. Okay, and I need to ask myself, is this a true statement? Okay, is 0 greater than or equal to -1? And the answer is yes. Yes, it is. 0 is greater than or equal to -1. So that means I can shade in this whole side of the graph. So that's better shading, I think. Looks nice and light. Okay, shade in this whole side here with my pencil just nice and light. Doesn't have to be dark. Showing that all of these, whoa, what just happened there? Oh no, showing that all of these are part of my solution. Okay, so all of these points, if I were to plug in any one of these points on this side of the graph, it would make this inequality true. Okay, so now let me just test that theory. Let me plug in the point 1, 1. If I plugged in 1, 1, I have 1 is greater than or equal to -3 times 1 minus 1. This is -3 minus 1. Gives me -4. Is 1 greater than or equal to -4? Yes, it is. So therefore, that is part of my solution. If I were to plug in the point, let's plug in -2, 0. So I plug in -2, 0. So I have, if I plug that in, I'll have 0 is greater than or equal to -3 times -2 minus 1. Okay. -3 times -2 is +6 minus 1 is 5. So I get 0 is greater than or equal to 5. Is that a true statement? And the answer is no, it's not. Okay, because 0 is not bigger than 5. 0 is smaller than 5. And so because of that, this is not part of my solution. That's why I'm not shaded on this side of the graph. Okay, all of these points would make this inequality true. These ones would not. Let's just look at, I don't want to do this one. Let's look at this example. Last example. Okay, so y is greater than or equal to -6/2x. So I need to graph this first, just like I would graph any other equation. So do I have a y-intercept? And the answer is no, there's nothing here, but that's always the same thing as just having like +0. So when there's no y-intercept here, that means we go through the origin. We go through the point 0, 0. Okay. Now I graph my slope -6/2. So because it's negative, I'm going to go down 6, and then I'll go over 2. 1, 2, 3, 4, 5, 6 over 2. 1, 2, 3, 4, 5, 6 over 2. Okay. So then from here, what I want to do is I need to determine, do I use a dashed line or solid line? Because it has this or equal to symbol underneath, I'm going to use a solid line. And it's supposed to be straight, but that's not. Sorry. Okay, but I need to use a solid line because that means that this whole graph is part of the solutions to my inequality. If I plug in any point on this line, it would make this inequality true. Okay, and then now I need to figure out which side of the line do I shade on. The thing is, I cannot use the point 0, 0 here because it's part of my line. If I plug in 0, 0, I'm going to get 0, 0 minus 6/2 times 0. And that's going to be 0 is less than or equal to 0. I get the same exact thing. And yes, this is true because of the or equal to, but that's on my line. So that doesn't help me determine which side is my solution. Okay, so I'm going to use another really, really easy point. And I like to use the point, if I can, 1, 1. I think 1s are really easy to work with because I get 1 is greater than or equal to -6/2 times 1. So 1 is greater than or equal to -6/2. Okay. -6/2, you guys, isn't that just -3? Is 1 greater than or equal to -3? Okay, and the answer is yes, it is. 1 is greater than or equal to -3. So because of that, this side of the graph is my solution. So I can go ahead and shade over here. And I'm done. All of these points are part of the solution to this inequality. Okay, so that's it, you guys. So the biggest thing is we need to follow those steps, graph it like you normally would any equation in slope-intercept form, but then we just have to determine if it's solid or dashed line, and then we have to shade it on the correct side, whether it's on the left side of the line, the right side line, above it, or below it. It doesn't matter, okay? So if you guys have any further questions, please let me know, and good luck with this, and yeah, thanks for watching.